different forms of sugars come in different forms. And so there are several sugars that we think of as monosaccharides, and there's then some that we refer to as disaccharides. So those would include things like maltose, and maltose is comprised of two glucose molecules. Lactose, which is actually glucose and galactose, and then sucrose, which is table sugar, by the way, which is glucose and fructose that have been combined. So these are formed through dehydration. Remember in the very beginning of this chapter, I showed you all how basically you're forming an ether and you're removing water in there. Well, let's look at how we actually do that. Okay, to form lactose, what we're combining is a beta-D galactose with a beta-D glucose. So here we have the beta-D galactose in Haworth form, and we have beta-D glucose right here. Well, what ends up happening is the part that I have circled here. So the H from one of these guys and the OH from down here makes the water. That's what this guy is. That's what the water is, which means that we get a new bond between this oxygen right here and this carbon right here, but it still goes in the same direction. So we basically have to take this entire thing and move him up a little bit, and that's what we did right here. So this oxygen that I've got right there that's between them is the same one that we had right here, okay? Now when we name those things, we have to be careful how we do it because we're combining one thing to the other. And we read this sort of left to right like you would anything else. So since this guy is beta and this O is still pointing upwards, that's why we call it beta down here. This is the first carbon if we're looking at all of those. And this right here would be carbon number 4. Remember, it would be 1, 2, 3, 4. So we call this a 1 to 4 glycosidic bond. So the carbon number 1 on our left is going to carbon number 4. We have to define that carbon number 1 that's involved is a beta because it's on carbon number 1. If it wasn't on carbon number 1, we wouldn't have to worry about it. But since it is, we need to tell people which are we talking about here. Okay. So let's look at another example. If we're looking at maltose, or alpha maltose specifically, then we've got 2 alpha D glucose that are involved. I'm going to use a different color here. Go. Okay, so see how I've numbered these carbon as 1, 2, 3, 4, 5, and 6. And then I did the same thing on the other side. So 1, 2, 3, 4, 5, and 6. This guy had an alpha going down. That's where this alpha comes from. And this would be coming off of the first carbon, and we're linking to the 4th carbon. So this would be an alpha 1,4 glycosidic bond. Okay. Next, let's look at sucrose. And sucrose involves 2 alpha D glucose, an alpha D glucose and a beta D fructose. So fructose is exciting because remember, it's got that 5-membered ring here. Well, when we can't go left to right, we sort of go top to down in this case. So again, I've numbered for you the carbons that are there, and I've numbered for you on the bottom the carbons that are there. On the top guy, this is going down to reach that oxygen. And so since it's going down, we started off with the glucose having an alpha, and that's where this alpha comes from. On the other hand, the fructose has a beta because it's coming up. And so what we do is we say we have an alpha, beta. One is referring to the alpha, two is referring to the beta. That's why we keep them in those orders. So the first thing is alpha, the second thing is beta, glycosidic bond. So here, that determines both alpha versus beta. In each case is joined between an oxygen. So we have to indicate which each of them are. It doesn't happen as often, but it is in sucrose, and that's table sugar. So that's probably the one thing that you're most familiar with. Okay, there are several other types of things that you need to be familiar with, and you need to probably read up on these. We have things like that are part of starch. 20% of starch is what's called as amylose, and it's basically 250 to 400. That is a lot of these structures of just alpha D glucose that have these alpha 1,4 linkages. And so, yeah, you need to know that amylose is alpha 1,4 linkages of alpha D glucose. Okay, and I know that's a lot to know, but that's gonna come back, so you need to make sure that you know that, okay? Amylopectin, which is 80% of starch, it looks a lot like this amylose, but about every 25 units or so, it's branched by alpha 1,6 linkages. In other words, it also is comprised of this alpha D glucose, but every 25 units or so, it's got these little things that come off. So it makes it kind of like it's got these little spirals that are coming off, and it makes it sort of sticky or something. Next, we have glycogen, and glycogen is like the animal version of amylopectin, but it's got even more branches. I think that has those branches coming out maybe every 10 units or so. And finally, we have cellulose. This is different. This isn't an alpha 4 linkage. This is a beta 1,4 linkage. And since we don't have the enzyme to break that down, we can't. We can only deal with the alpha 1,4 linkages. So yeah, that's the reason why you can't go chew on a tree and get, energy from it. Okay, guys, that's a lot. You might need to watch this more than once. That's okay. Talk to you soon. Thank you.